Hello, my name is Artem Moskolev. I will present our work, Contrasting Quadratic Assignments for Set-Based Representation Learning. This is a joint work with Ivan Sosnovik, Volker Fischer, and Arnold Smulders. Let us start. The standard approach to contrastive learning is to maximize the alignment between different use of the data, ordered in pairs. Practically, the contrastive learning aims to maximize the alignments in positive pairs, while negative pairs are needed to avoid collapse. Many existing contrastive learning methods follow this paradigm. In this work, we note that the approach of considering individual pairs cannot account for both intraset and interset similarities when the sets are formed from the views of the data. For example, this picture demonstrates two scenarios of positive pairs with different representations. Yet, the total pairwise alignment is the same in both cases. Thus, the approach of considering individual pairs limits the information content of the supervisory signal available to train representations. In this work, we propose to go beyond contrasting individual pairs of objects by focusing on contrasting objects as sets. For the same example, the set similarity objective yields different set similarities, while the total pairwise similarity is the same. To sum up, we propose to learn representations by contrasting objects as sets rather than as pairs of individual instances. We derive a computational efficient implementation, where the set-contrastive part is implemented as a regularizer for existing contrastive learning methods, and we conduct experiments. To construct set similarity, we turn to assignment theory, and specifically, we consider a linear assignment problem, where the goal is to find the maximum similarity matching in a bipartite graph. We next consider a problem of learning to produce correct linear assignments, which can be done by a structured prediction framework to define the following loss function. We note that this loss generalizes many existing contrastive learning methods, like triplet loss or info-NCE objective. In this work, to construct the set similarity objective, we propose to generalize an underlying assignment problem from linear to quadratic, where the quadratic assignment problem goes beyond pairwise similarities. While the linear assignment problem matches individual instances based on pairwise similarities, the quadratic assignment problem matches the sets of interconnected instances based on graph similarities. Formally, the quadratic assignment problem extends linear assignments by including the quadratic comparison term between sets of objects. We next consider a problem of learning to produce correct quadratic assignments through the following loss function. Please refer to the paper for more details. We next derive a tractable approximation to allow contrasting quadratic assignments. The approximation boils down towards regularizing the pairwise contrastive loss, for example, sim-CLR or info-NCE objective. We term the resulting regularizer as care for quadratic assignment regularization. To verify the effectiveness of the quadratic assignment regularization, we conduct the instance matching experiment. In this experiment, we contrast objects from different views to train a common representation space for matching. We extend conventional contrastive losses with the proposed regularizer. With this, we observe up to 4% improvements in the matching accuracy. We also conduct self-supervised classification experiments on CIFAR10, CIFAR100, and tiny ImageNet datasets, with self-supervised classification being an established benchmark for contrastive losses. We extend sim-CLR and the sparse CLR objective that we additionally propose in the paper with our quadratic assignment regularization. With this, we observe up to 3.6% improvements in the self-supervised classification accuracy under a linear probing protocol. All in all, in this work, we propose to learn representations by contrasting objects as sets. We consider the contrastive learning through the lens of assignment problems. We extend contrastive losses to quadratic comparisons to implement the set-contrastive objective. We derive the computational efficient implementation of the set-contrastive objective, and we conduct experiments. Check our code, check our paper. Thanks.